Dr. Ranjani Parthasarathy is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. This is a series of lectures on computer architecture. This is basically what we have been looking at for the past 2 episodes or so is an introduction to computer architecture. So, we are more or less continuing on that same introduction. What I am trying to do is just give you an overview of computer architecture, introduce you to certain terms and concepts more from a very top level, so that you kind of understand what is happening in a computer, and then we will start looking at more details of what happens in each for each component or for each operation to take place in detail later. But what we are trying to understand right now is a big picture. Okay. So, continuing on the same big picture, we will look at what actually happens when an instruction is executed in today's lecture. Okay. So, let us look at this big picture that we have in terms of the data path, which shows the different modules of the computer being interconnected to one another. Okay. So, what we have shown here is control logic and what would normally be there within a processor, that is highly abstracted of course, but we have just talking about some control logic which will control the different components which are there in a computer. So, now here as part of the processor again we would have we said there will be an ALU or an arithmetic logic unit, and there will be a register file which basically consists of multiple registers, and then you will have input coming into this ALU from the register files. The ALU would do the actual operation, some arithmetic or logic operation, and the output could be stored either back into the register file or the output may be stored in a memory. So, we have some a memory module and we have an interface for the memory module. So, the interface for the memory module will consist of what is an MAR or what is called as the memory address register, and then there is an MDR which is the memory data register. Now, to recollect what we do with the memory address register and memory data register, normally what happens is memory consists of different cells where the data is stored, and these cells are addressed by means of some, they are actually given some address. So, the address has to be specified in this memory address register, and this memory address register will pass on that the address to the memory, and then if you say either a read or a write operation to this memory, the data will be stored in the data register. That is, if it is a read operation, then the on specifying the address, data from the memory will be stored in this data register, which can then be taken by the processor, either stored in a register or used for some other purpose. If it is a write operation, then when you specify the address, along with specifying the address, you will also specify the data that is be written into that memory location, and you give a signal called write to this memory, and the data will be written into this memory. Okay. If it was an input or an output device, it is not shown in this picture. Similarly, you will have some registers to which you will be doing a write or a read operation, depending on whether you want to input from the device or output to the device. Okay. So, let us now try to look at the different functions that we have in the execution of an instruction, and look at what exactly happens with this with respect to this picture of the processor that we have. This is a very abstracted picture that we are looking at, but it is enough to understand the basics of what actually happens within the processor. So, coming back to the instruction cycle, that is the different steps that are involved in the execution of an instruction, we have these following steps. First is a fetch. Now, what is the meaning of a fetch? Fetch would mean that I am fetching the instruction from memory. Now, in a stored program computer, which is the model that we are normally familiar with, what we do is we have programs which are stored in memory. So, what is this program? Basically, it is a set of instructions. So, in order to execute an instruction, what we need to first do is fetch an instruction from a given memory location and bring it to the processor. Okay. So, this is the first step that will be done, which is called as the fetch step. So, look at what are the sub steps which are involved in this. So, in order to fetch, therefore, I need to first access memory. So, to access memory, I will have to specify the memory location. Now, how do I specify this memory location? I should know the address at which the instruction is available. Let us assume that I know this address. So, if that address is known to me, I can give that address to the memory address register and ask the memory to fetch that particular value for me. So, once I get that, that value will be available, and I can store it somewhere. If you look at this picture that we have, let us look at what will happen. Okay, where will I normally store this again? So, look at what we talked about right now. Some address was given to the memory address register. This address is the address of the instruction that I want to fetch. Okay. So, I said we will assume that this value is known to us somehow, and normally this address would be stored in this program counter. This program counter is a special register which will be there in the processor. This program counter will have the address of the instruction that is to be executed next. So, assume that I have loaded this program counter with some value. So, that value now would have been passed on to this memory address register, and I will tell the memory to fetch the data for me. So, that data will now be fetched by the memory and made available in the memory data register. From the data register now I can store it into this instruction register. Now, this instruction register is what is going to store the instruction for me. Using the information in this instruction register, the control logic will generate the necessary control signals. So, this is the first step. So, fetch basically will mean taking from the PC, storing the value into the memory address register, that is giving the address to the memory, then taking the data which is fetched from memory, which actually is the instruction in this case. This instruction will now be stored in the instruction register. So, this is our first step or the fetch step. Now, second step is the decode step. What does the decode step involve? Again, let us look at the same figure. Now, we have the instruction already available in the instruction register. So, this instruction that is available, we know that the instruction will consist of an instruction opcode, and it will consist of the different operands on which the operation has to be performed. Opcode is the operation code. Okay, so, which will tell me whether I need to do an add operation or a subtract operation or whatever operation that needs to be done. So, I have that information available in this instruction register. So, that decode has to be done by this control logic. So, we will have some kind of a decoder or some circuit that is available which will identify the type of operation to be performed, right. So, that is the decode process. So, that is the second step. Third step is the evaluate address process. Now, in order to perform the operation, you may have to again fetch some data from memory, in which case you may have to find the address at which that particular data is located. So, to do that I may need to do some address operation, right, that is calculation of address. How do I calculate address? Again, the address may be directly available in some register, in which case I can take it directly from the register. Sometimes it may not be directly available in a register. I may need to add some value to that register in order to generate the address, in which case evaluate address will consist of taking the data from that register, adding some value to it, and then finding out what the effective address is. Okay. That address will what will have to be given to the memory, and then you will have to fetch the data from that location. Okay. So, this is what would be involved in an evaluate address step. So, again if we go back to this picture here, so for evaluating address I may need to fetch some data from the register file. Now, which register I need to fetch from, that will be available for me from the instruction register, because that will be part of the instruction. Okay. So, I will know that I will have to fetch from the register file, maybe add some other value to it, perform some operation based on that, and that value may be given to the memory address register or it may be stored in some register. Okay. This is what would normally be done in the address calculation step or the evaluate address step. Then we actually go and fetch the operands. Okay. So, fourth step is a fetch operands step, where if it is a memory operation I will have to fetch the operands from memory. If it is not a memory operation, and let us assume that we did not have to go to the memory at all to get the operands, that is the operands are available in the register itself. Then the fetch operands step essentially means get the data from the registers and give it to the ALU. Okay, that is what it will be, that is the data will be available in the register file. From the register file I will be giving it to the ALU. All I need to specify is which register in this register file has to be selected and its output has to be given to the ALU. Okay, that is what this step would involve. If it was a memory operation, then I will have to give the if I have already given the calculated the address, give that address to the memory address register and then give a read signal to the memory, get the data in the data register, take this data and use this data as one of the inputs to the store it in the register or use it as one of the inputs to the ALU. This is what we will have to do. So, that would be the fetch operand step. Then you have the execute step, which will actually execute the instruction, that is you are giving control to the ALU. You have already given it the operands, and these operands you have given the operands to the ALU, you are specifying what operation needs to be performed, and once you specified that, the ALU will do the operation. This is the execute step. Once we have executed it, now the result is available at the output of the ALU, that will have to be stored. So, that is the last step, store result. Now this storing of the result, maybe you may either have to store it into memory or you may have to store it in the register file. If it is stored to the register file, then depending on the instruction, the output will be stored back into the register file, or if it has to be stored into memory, the output of the ALU will be given to the memory data register, an address will be specified, and you will actually do the memory operation here. So now we will take a particular example and see how the data flow actually takes place for each of these steps. Okay. So let us look at this, the first step of our fetch. We said that what do we need to do for a fetch operation? The control logic will have to tell two people. One is tell the PC to make sure that whatever address is available in the PC is output onto this bus. Remember, this bus is our communication mechanism between the various registers, between these various devices here. Okay. So if anything has to be stored from anywhere to anywhere else, it will have to be put on the bus and it has to be taken from the bus by the corresponding unit. Okay. So look at what the control logic will do now. The control logic now is generating a signal, generating a signal to the PC, telling the PC that you output whatever data you have here, that address that you have here onto the bus. So that address now is available on the bus. Okay. Now at the same time, the control logic tells the memory address register that you take the value that is available on the bus and store it inside. Okay. So it is giving one more control signal here, telling the memory address register that whatever is there on the bus, you take it and store it here. So something is being put onto the bus and that is being stored onto this address register from the bus. Okay. So by means of this control signals, you are taking the value available in PC, which is the address, and storing that value in this address register. This is the first part of the fetch step. Okay. Second step, what do we need to do now? Now the address is available here, okay, in the memory address register, and now you have to give a control signal to the memory saying read from this location. So the control logic now sends out a control signal to memory, and it also tells the memory data register to store the data that is coming in from memory, right, and store it and put it into the memory data register. Okay. These are two things that need to be done. Okay. So the control logic now, remember that the control logic is responsible for specifying what needs to be done and also for specifying it in the right sequence. Okay. Which is why you can see that if you look at the fetch operation itself, there are 2-3 things to be done and they have to be done in a particular order. Okay. That is very important. So first we had to load the address in the memory address register. Now you tell the memory to look into that address and then read from that address and give the data out. Now that data is to be stored in the memory data register. So that is what we are specifying over here. In addition to this, the control logic normally does one more thing in the same fetch stage, which is that it gives a signal to the to a special unit that we have here. We have not talked about this so far, we only talked about the program counter, but you can see that this program counter's output is also connected to another small unit here where we have shown a +1. A +1 basically indicates that I am incrementing this PC value by a value of 1. Okay. So I am just adding 1 to this PC value. Now why would I do this? This is done to fetch, to point to the next instruction. Okay. We said that the PC or the program counter points to the current instruction or the next instruction that is to be executed. Now earlier it was pointing to the instruction that has just been taken up. Now it has to point to the next instruction. So in order to do that, I need to increment that value by 1. Okay. So we have a small dedicated adder unit here which will just take the PC value, add 1 to it, and that value will be stored back into the PC. So now the PC becomes ready to fetch the next instruction, or the address that is required to fetch the next instruction is stored in this PC. So this also is normally done as part of the fetch step itself. That is, once I have got the used the address that is available, I have now become ready to fetch the next instruction, keep that value ready in the program counter. So that is also done in the same stage. It can be done in this stage or it can be done later also. In this example, we are assuming that it is done as part of the fetch stage. So once I have used that value, I can now load it with another new value. So that is what we are doing here. Okay. So in this second stage of fetch, we are doing this kind of these two operations, that is giving control to the memory and also giving control to the PC. We will take a short break now and come back and look at the rest of the operations. Welcome back after the break. So we were just looking at the operations that are required for instruction to be executed. So we looked at the fetch instruction or the fetch stage of the instruction. So, we looked at two steps in fetch. The first step in fetch is this, that is the control signal gives a control to the memory address register and to the PC. Telling the PC you put out the data that you have, the value you have onto the bus, so that the value can be copied into the memory address register. So, it gives two control signals to these two fellows, the PC and the memory address register. In the second step, what we saw was it is giving control now to the memory, telling the memory to read at this particular memory address register and put the value in the memory data register. Okay, that is something it does. In this, it also does one more thing in this step, which is telling the PC to increment the value by 1, so that the PC will now be pointing to the next instruction to be fetched. Okay. So, before that, let us first complete this instruction execution. Okay. So, if you look at this instruction execution now fetch, what has happened in the fetch stage? So far I have specified the address and got the value in my data register. So, what do I need to do next? Next I need to take the data from this data register and store it into this instruction register. That is when my fetch will be completed. Okay. So, control logic now gives two control signals, one to the MDR, the memory data register, and one to the instruction register. Telling this fellow you have to put out your data onto the bus, telling the instruction register that it has to take it from the bus and store it in the instruction register. Okay. So, this completes our fetch step. Okay. Now, what is the next step? Next step is our decode step. So, what is decode supposed to do? Decode is something which happens pretty much internally to the processor, that is the value which is there in the instruction register, okay, that is taken and understood by the control logic as which part of it is the opcode, which is the source operand, which is the destination operand. What do you mean by source operand and destination operand? For any operation there is a source and a destination. What is a source? Source is the register or whatever on which an operation is performed, destination is where the result will be stored. Okay. So, identifying what is that operation to be performed and what are the various source operands and destination operands, all this is done in the decode stage, and all this happens as part of this this block over here, that is the control logic from the instruction register determines these things. Now, based on that the control logic is now going to execute the next set of instructions. Okay. So, this completes our decode process. What is the next process? Next step we said may be evaluating an address. For instance, suppose I have an instruction where we have said that you need to add the contents of register 3 to the value of 6 in order to find out the address. Let me assume that this was part of the instruction that was specified here. So, the instruction said that in order to get the address you have to add the contents of register 3 to the value of 6. Now, where is this value of 6 specified? It would be there as part of the instruction itself. So, which means, so the value of 6 is already available in the instruction register, okay, that has already been read by the control logic. So, the control logic now says gives the value of 6 directly to the ALU, and then it also tells the register file that you need to now output the value of register 3 here. So, register 3 information is given to the register file, so that from register 3 the data will be taken out and given to the ALU. So, once this is done, the ALU will perform the addition, okay, and then that value will have to be now stored, have to be given to the memory. Okay, this is what is done in this evaluate address step. Next step will be the fetch operand step. Okay, in the fetch operands step, what is it to be done? Now, what I have got is I have got the memory address and I might have got one data from that memory address, or as I said, you may have to just fetch the operands from the register itself. Okay, let me just go back one step. If we go back to this evaluate address step, this evaluate address step may not be necessary for all operations. That is, if it is a memory address that needs to be calculated, then this evaluate address step will be required. If it was not a memory address operation, if it is not an instruction which involves a memory address operation calculation, this step will be skipped. Okay, it will not be required. Okay. So, in which case from the decode stage, next step would be fetch operands directly. Okay. So, if we were, let us say we were to do that. Okay. Now, if you are doing a fetch operands directly, then what is it that the control logic will have to do? It has to specify there may be 2 operands that are required. Okay. So, it will have to specify which are the 2 operands that are required to be read from the register file. So, there may be 2 inputs coming from the control logic telling the register file that these are the 2 registers that you will have to produce as an output. Okay. So, those register values will be given to the ALU, right. So, that will complete the fetch operand step. If there was a memory operation that was involved, then the fetch operand step would also will have already we would have evaluated the address. So, the address would be given to the memory and the data will be fetched from here, and that will be given as the input to the ALU. Okay. this is what would happen in the fetch operand step. The next step we said is execute. Once you have got the operands, next we just need to do the execute operation. So, the execute operation now involves giving control to the ALU. So, you have to tell the ALU what is the operation to be performed. The ALU has got the inputs in this from the register file on its input lines, and once you tell the ALU to perform a particular operation, the output will be produced by the ALU, and that would complete the execute step. The next step will be our store result step. Store result is the output is available on the at the output of the ALU, and that has to be stored either into a register or into memory. Again, the store result could be of two types. One is that you are storing a result into register or storing a result into memory. So, let us look at the simple one first, which is the storing the value into a register. So, what will be the control signals required for that now? So, you have to tell the register file to take the data which is available on the data bus, right, which would typically be available at the output of the ALU. You may actually have one more control signals which is explicitly specified to the ALU, telling the ALU to output the data onto the data bus. That may also be necessary. Okay. Again, it depends on the bus structure and so on. Let us not worry about those details now, but right now assume that the output of the ALU is available on the bus. So, I have to tell the register file now to store the result. Okay. Of course, I have to tell the control logic will tell the register file as to which register, into which register the value has to be stored. Okay. So, if I had something like add R1, R2, R3 as my instruction. So, what is this R1, R2, R3? Add is the opcode, specifies the opcode, that is the instruction to be performed. R1 and R2, let us say, are our two operands on which I need to do the operation. So, this is my source operands. R3 can be my destination operand. So, what am I expecting to do? R1, contents of R1, contents of R2 are to be added, and the result is to be stored in the register R3. Okay. Suppose this was my instruction. So, in this case, in this store result stage, what the control logic will tell is, it will tell the register file R3 is the register into which this data has to be stored. Okay. So, that would complete the store result stage. So, you can see that with these 6 steps, the entire process of instruction execution will be completed. Let me just take the same add R1, R2, R3 and go through this entire sequence of steps. Then we will take another instruction which involves a memory address calculation and see how the sequence of steps will be carried out. So, add R1, R2, R3 is our instruction. Okay. What is the purpose of this instruction? Add the value that is there in the registers R1 and R2, store it in R3. Okay. Let us take the simple case. So, first step is our fetch. So, remember what is going to happen here in the fetch step. Add R1, R2, R3 has not yet come into the picture. We have to fetch the instruction first. So, to fetch the instruction, control logic gives control to the PC and to the memory address register. Okay. First step done. Second step of the fetch itself, telling the memory unit to take the address from the address register and produce the output in the data register. Step 2 over. Step 3, now you are telling the instruction register to take the data from the memory data register. Now, that will happen to that will have to take place through the bus. So, two control signals from the control logic, telling the MDR to put its data out onto the data bus, telling the IR to take the data from the data bus and store it here. Now, this completes our fetch. Now, is when our add R1, R2, R3 comes into effect. Okay. The instruction that is now there available in the instruction register is this add R1, R2, R3. There will be an opcode for add. So, that will be decoded here. So, now the control logic will decide that the series of steps that need to be performed. So, it is an add R1, R2, R3. So, there is no memory address calculation involved here. It is only a register based operation. So, because it is only a register based operation, so what will the control logic do now when it does this decode operation? It determines what is the next sequence of operations to be carried out. Okay, that is what this control logic will do. Okay. So, now that it is only a register based operation, there will be no evaluate address step. This step will be skipped. No address needs to be calculated. So, we will directly go to the fetch operands step. So, in the fetch operand step, what will I do? Now, we know that two registers R1 and R2 have to be fetched. So, that information will be now given to this register file from the control logic. So, R1 and R2 values will be given to the ALU. So, next step will be execute, where you will tell the ALU the operation to be performed. So, now we know that add was the operation required over here. So, the control logic now would give the control signal as add here. So, the add operation will actually be performed over here in this ALU. Once this add operation is completed, this add operation result will now have to be stored. Okay. So, where is the result to be stored? the instruction is add R1, R2, R3. So, it has to be stored in R3. Okay. So, R3 is what is a register that needs to be specified by the control logic, and the output from the ALU which is there on the bus has to be stored in the register file. This is an overview of what would happen for a simple instruction like adding two registers and storing it into the register output file. Okay. Instead of R1, R2, R3, suppose I had specified add the contents of the location specified by R1. R1 gave me the address of the memory location rather than the direct value itself. In that case, then I will have one more step which will be my evaluate address step. Okay. In that case, what would happen? I will have to go get the value which is go to that memory location which is specified by R1, fetch the data from there, bring that to the ALU, and then add it to the contents of R2 and then get the output of R3. So, that is a little more involved. We will look at details of that when we look at the complete data flow in detail in later classes. But right now, with this picture of the of just a few registers and the ALU and the control logic, you should get some idea of what is actually happening inside the processor. Now, there is one more step here. So, remember we had calculated incremented the PC. So, to now access the next instruction, all we need to do is that address is already available at the fetch. So, you have to now initiate the next fetch. So, once you have stored the result, one instruction execution is over. So, the next instruction execution will start by just following this same step of events over and over again. So, if you follow the same step of events over and over again, a sequence of instructions will get executed automatically. Of course, it does not take care of jumping to a different address and so on. That would require different type of operation. But if it is just a sequence of instructions to be executed, you will find that this kind of a method works pretty well. Okay. So, there are certain other things that you need to observe as we looked at this series of operations and what really happens over here. So, remember instructions, data and addresses, okay, they are all stored and represented in pretty much the same way. That is, instructions are taken from the memory, data is also taken from the memory, and the memory really does not differentiate between whether it is an instruction that is stored in a particular location or whether it is data that is stored in a location. It is how the program interprets it or how the processor interprets it. Okay. So, there is really no distinction as such between an instruction sitting in memory or data sitting in memory. Memory just has some value, whether that value is an instruction or that value is a data or that whether that value is the address of something else, all that is subject to interpretation. Another thing we have is that the registers, okay, these registers or the general purpose registers are a very important part of computing in a typical processor. So, how these registers are handled is also very important. And as we saw, these general purpose registers again can be used for holding the data or addresses. There is no distinction at this level, and it is by manipulating these things that we are able to have more complex instructions and have real complex programs that can be designed. Okay. So, to summarize, what we have looked at in today's lecture is the various steps that are involved in the execution of an instruction, and we have seen the flow of signals, that is how the controls flow, the control signals flow, and how the data flows on the data path. Okay. When I say data path, we are talking about the connection that we have between the different units either through a bus or some direct connections that may be available. We have also looked at some of the registers that are involved, and we have looked at the purpose of each of these registers. Okay. So, a big picture in terms of an instruction flow is what I have tried to give in this particular lecture. So, a set of simple questions as usual to identify whether you have understood the contents of today's lecture. Question number 1, identify the operations and flow of signals in the fetch stage. Question number 2, what happens in the decode stage. Question number 3, why is the PC incremented. Question number 4, how does memory access take place. Question number 5, how does a simple add operation work. Thank you.